Hey everyone, today's science lesson is about physical and chemical changes and how to tell the difference between them. A physical change is the change in the physical characteristics of a substance. That's kind of big words for saying that the thing is going to change in the way it looks or appears, like in size or shape, but it's still going to stay the same thing. For example, I can cut up a cucumber. I cut it up into slices, but it's still a cucumber. It hasn't changed what it is.
So in a physical change, the substance or thing stays the same. This is a cucumber. Yep, it's a cucumber. This cucumber is going to stay a cucumber even though I change it. I'm going to cut it with a knife. Now, don't do this at home unless your parent or whoever takes care of you is with you and is okay with you doing this. And I'm not using a very sharp knife. So I'm going to cut this cucumber. It's smaller, it's changed size, it's changed shape a little bit, but it's still a cucumber. Yep, still a cucumber. That's a physical change. There was no odor other than the smell of the cucumber, which is there anyway. There were no bubbles. It didn't take any heat. It didn't give off any heat.
I can tear a piece of paper into little bits. It's still paper.
If I take this piece of paper and I tear it, it's still paper. It has not changed what it is.
And oftentimes the process is reversible. In other words, I can tape my piece of paper back together.
And theoretically, I could go back. I would need some tape. I would need a lot of tape. But it hasn't changed what it is. There was no odor given off other than the smell of the paper, which was already there. There were no bubbles. There was no color change. No heat was given off.
In the terms of water, when water changes state between a solid, liquid, and a gas, again, that's a physical change. It's changed its shape, but it's still water.
Now, this one can be a little bit confusing because it does take heat to melt the ice, but it still is water. This is frozen water, ice, and this is melted water, just plain water. And I didn't want to use something hot here, but if I had created steam or water in its gaseous form, it's still water. I can go back. I can condense the steam back into liquid. I can melt the ice back into liquid. I can turn the liquid into ice. No color change, no bubbles. It's still a physical change.
So to review, if a change is a physical change, the substance will not change what it is. It will still be whatever it was when you started. It may have changed shape or size, but it is still the same thing. You also will not have a color change, there will be no new odor, and you won't have any bubbles. In a chemical change, it will be often pretty obvious that something has happened. There may be a color change, or you may get a new and different odor. Bubbles may form, but always the substance changes into something different. You can't go back. It is now a new, chemically different compound. Heat may be used or produced during a chemical change.
So let's look at some chemical changes. I'm afraid I don't have a regular banana because I've eaten them. But here you can see a banana after it is starting to undergo a chemical change. Notice the color change. And you'll notice it smells sweeter, and after a while it actually starts to smell bad. But you had a color change and you've had an odor that's been given off. And this is a chemical change that's taking place in this banana. Let's look at rust. So here I have a screw that is not rusted, and here I have a nail that is rusted. And you can see there's a color change. This is still silver, this is not anymore. It also feels different. This one has a stronger smell. And also if I scrape it, some of that rust comes off. It's actually chemically something different. It was iron in this case, and it's slowly being turned into iron oxide, a different chemical substance. And I can't go back. So there was a color change, and it is not reversible. This is a chemical change. You see a lot of chemical changes in cooking and baking. Here it's just an ordinary piece of bread. Here I've toasted it, right? There's been a physical change. Well, I cut it in half, but there's been a physical change. It's a little bit smaller. But look at the color change. I've had a definite color change, and it's different. And if I smell it, it smells different. This smells like bread, and this smells like toast. Delicious. So, if you think you've seen a chemical change, you're looking for a change in color, an odor that's given off. There may be bubbles that form. Sometimes it requires heat, sometimes it gives off heat. But usually you can't go back. You can't get back to the original thing. It is now changed into something different.
Now let's do an experiment and see if you can recognize whether it's a physical change or a chemical change.
Okay, now it's time for our experiment. If you can't do this at home, that's okay. Just watch till the end of the video. I'm going to do it for you, but it's really cool if you can do it yourself. First, make sure you have your parent or guardian, whoever takes care of you, make sure you have their permission to do this. I'm going to be using a glass measuring cup, so if you're going to use glass at home, again, make sure your parent or whoever takes care of you knows that you're using glass and is okay with that. You don't have to use glass, though. You can use a metal measuring cup or a plastic measuring cup. So here's what you need to do this experiment. You're going to want a table that you can work on that can get liquid on it just in case there's a spill. You're going to need a measuring cup. You're going to need some baking soda. You're going to need 2 empty water bottles. You're going to need some plain water. You're going to need some vinegar. Doesn't matter what kind. You're going to need a measuring spoon. And you're going to need 2 balloons if you have them, work really well. But if you don't have them, sandwich bags will work perfectly well. Okay, so the first thing I'm going to do is I'm going to measure off some water. For this experiment, my measurements don't need to be exact, but for a lot of science experiments, your measurements do need to be exact. So I'm going to show you how to measure. We're going to measure off ½ a cup of water. So the line right there for ½ a cup, I'm going to set it on a flat surface, and then I'm going to kind of look sideways. If you look from above, you won't get a good measurement. You have to look sort of sideways to get a good measurement. So I'm going to pour my water until it comes right up to that ½ cup line. And then I'm going to pour my water into one of my bottles. Carefully so as not to spill. So that's the water. I'm going to do the same thing with the vinegar. I'm holding it up just long enough so I can get the pouring started, but I'm going to set it on a flat surface so I get the right measurement. And I'm going to pour ½ a cup of vinegar. And I'm going to pour the vinegar into another bottle. This is a different bottle. Don't pour it into the same one that you've got the water in. Okay, now I'm ready for my baking soda. So this is the vinegar, this is the water. I'm going to take one of my plastic bags and I'm going to open it. And I'm going to put a ½ tablespoon of baking soda. Again, the measurements don't need to be super precise on this. And I'm going to drop it into my Ziploc bag. I'm going to take the other ½ tablespoon is what I'm doing. Drop it into this bag. I'm going to set this to the side because I don't need it anymore. Okay, I'm going to have to make observations first. The first thing I need to do is I need to observe the liquid. It's clear. I'm going to try to use all 5 of my senses. In science, never put anything in your mouth that it's not safe to do so. Always follow the safety rules, but I'm using just household supplies that are perfectly safe. Baking soda goes in food, and this is just plain water, so it's safe. I'm going to look at my water. It looks clear. My powder, I measured how much. Same thing for this. It's the same stuff, so it's going to look the same, but I need to log my observations. All right, so for the first one, I'm going to take my Ziploc. You have to leave the powder hanging down to the side. So I'm going to wrap the opening of the bag around the top of the bottle, and I'm going to make sure I get my fingers all the way around the bag. So I'm holding it really tightly around the top of the bottle. And I'm going to tip up my bag, and I'm going to drop the powder in.
This is where you want to stop the video if you are going to do this experiment yourself. Do the procedure I just showed you on the water bottle first. Record your observations, noting anything that happens or changes. Use all of your senses except taste. Repeat the procedure with the bottle that has the vinegar in it. Make sure you have a good seal with the baggie around the top of the bottle and record your observations. Come back to the video when you are done.
All right. I don't see a color change. I don't see any bubbles. I see the powder down in there, but you can see it's pretty quickly settling to the bottom, and the water is clear. There's powder on the bottom. I don't know if you can see that. There's the powder on the bottom, and the water is clear. So not a lot really changed. Nothing much happened. There was no color change, no bubbles, no extra odor. Nothing has changed. I could go back. If I wanted to, I could evaporate the water off, and I would still have my baking soda left behind. So that was clearly a physical change. Let's try the vinegar. Same thing. I want to wrap my fingers. I'm going to put the bag over the opening, I'm going to kind of hold the bag out of the way while I get my fingers underneath all of this bag. And I've got a really tight seal around the bottle with my hand. And I'm going to tip the baking soda in. Look at what's happening to the bag. Can you see what's happening to the bag? What do you see? Can you hear it? What happened to my bag? It filled up with a gas. Let's see if I can tip some more in. If I'm not careful, I'm going to wind up popping this bag. I can feel it pushing on my hand. Again, I've got a nice tight grip here. You want to make sure you get a nice tight grip here. But you can see that this filled up with gas. You can also see that bubbles formed. You can probably hear them fizzing away, right? And if I measure this, I'm guessing there is actually going to be a little less water or powder or the two combined, because some of it got turned into another substance. Some of this powder and vinegar got turned into a gas. It has changed substance. I can't turn that gas back into vinegar and baking soda. It has changed chemically. That is a chemical change. I had bubbles. I didn't have a color change with this one, but I did have bubbles, and I did produce a new substance. Make sure you log your observations.
Thanks for watching today's science lesson on physical and chemical changes. Be sure to check back with your teacher for any next steps.